Welcome to the ACX eLearning video on DHCP. Let's open up a browser and log on to the router, which has a built-in DHCP server, so we can take a closer look. As you can see here, we typed in 10.0.0.1, which actually is the gateway's IP address. Before we get to our DHCP server settings, let's take a closer look at our LAN settings to make sure it's set up correctly. As you see here, we have disabled the DNS relay. This is because we want the actual DNS server IP addresses to be forwarded to all client nodes on the local area network, which consequently reduces the amount of work the router must perform for external requests such as email, surfing, and downloading from the web. Here we see that the LAN is set up to be a Class A or 10 network. The router originally was configured at the factory to be a Class C or 192 network. At ACX, we prefer the 10 network because it is much easier to remember and type into our browser's URL location field and yields the greatest quantity of subnet IP addresses. The IP address of the router is in fact the gateway address, which is part of the pentagonal of required settings for a properly configured network. These 5 IP addresses are essential for proper configuration of any local area network. It is common practice to set the gateway IP address to the first available address on the network, which is always 1. This also makes life very easy locating the router from within a browser. The broadcast address is also a reserved IP and is always the base network number with the last octet of 255. This cannot be altered or edited. As we can see, it does not even appear in any of the editing fields. This IP address is exclusively used to broadcast messages across the network to all other nodes or PCs that will always listen on this channel. When a client node shuts down, it first uses this IP address to broadcast a message that it is leaving the network. The DHCP server hears this message and returns the allocated IP address for the client node to the DHCP unallocated pool, allowing it to be used by an alternate client node. The network address is also a reserved and non-edited value that contains the first 3 octets or positions of the network IP address with the last octet of 0. As we can see, this too does not appear as an adjustable value, but it is there. Next we have the subnet mask, which for small to medium networks is not a critical setting and does not adversely affect the overall configuration of your LAN. Common practice is to always set it to the maximum value for the Class A or 10 network as seen in the subnet mask box here. Last but not least, we have the client node or the IP address. For this, let's go over to the DHCP page and take a closer look. DHCP stands for Dynamic Host Configuration Protocol and is used to centrally allocate and manage TCP/IP configurations of client nodes or PCs on your network. DHCP can be a great help in building an intranet as it greatly simplifies the task of defining IP addresses in a system and setting up the correct address on each computer or client node on your local area network. DHCP allows you to specify pools of IP addresses which are then allocated to client PCs or nodes by the server or router. These pools are called scopes in DHCP terminology. Not only are the IP addresses handed out, so too are the related configuration settings like the subnet mask, default gateway, DNS servers, which as we already covered are required to make TCP/IP work correctly. IP addresses can be leased for periods of time, so an IP address that is not used for the duration of the lease is put back into the unallocated pool. This helps recover IP addresses that are no longer used. When a DHCP client becomes network aware, it sends a broadcast packet on the network with a DHCP request. This request packet is picked up by a listening DHCP server, which then allocates an IP address to the PC from one of the scopes or the pools of addresses it has available. This is where a little common sense and a bit of planning comes into play. In the IT world, subnets or groups are segmented by banks or ranges of numbers for certain types of client nodes that will reside on your local area network. As we see here, our DHCP range of addresses has already been configured and begins with 100 as the last octet for the first address, and ends with 199 as the last octet for the last IP address for the DHCP scope. The reason for this is simple. In the IT world, it is common practice and considered proper form for a small to medium-sized network to reserve IP addresses below 100 for static or fixed nodes. This leaves the range above 100 to be allocated to the DHCP pool or scope of available IP addresses. When this practice is employed, you will have a common and consistent network configuration protocol which will virtually eliminate mistakes and confusion whenever setting up your networks. It should also be noted that all ACX servers which automatically configure themselves utilizing DHCP at boot time to discover the network configuration will always be set to an IP address below 100 which will not collide or be in conflict with other IP addresses or client nodes on your local area network. This is because the ACX servers are actually intranet servers which make them client nodes in the context of the DHCP server, and must reside at a fixed or static IP address within your local area network for consistent and convenient access. As Internet servers, they will always belong to the static range or scope of your local area network. This makes setting up the DHCP range or pool a somewhat essential operation that, when done properly, will avoid confusion and headaches, especially in the context of an ACX deployment. Another modern and convenient feature of most routers is the static DHCP list or bank. This may seem like an oxymoron at first, because how can we have a DHCP address and a static address at the same time? This is simply a method that routers use to grant or allocate the same IP address for the same client node whenever the client node returns to the network after being disconnected for a period of time. This will greatly enhance and reduce the time it takes for a client node, especially a wireless NIC, to establish connectivity with the network. As we can see here, several nodes are part of this list. Notice that the Toshiba is seen twice. A closer look reveals that there are two separate MAC addresses for the same client node or name. This is simply because the two clients are actually two separate NICs or network interface cards on the same PC. One is a wireless NIC and the other a physical port on the same computer. For more on this topic, be sure to check out the eLearning video on MAC filtering. We hope this eLearning video is helpful and informative. Remember, when these practices are employed, you will have a common and consistent network configuration across all projects and installations. For more videos and useful tips, be sure to visit acxlan.com.